Hello friends, today here we are going to discuss the practical of DC machines and transformer. The first practical is the open circuit characteristics of the DC shunt generator. In this DC shunt generator, whenever the machine is going to work as generator, there should be one prime mover. We are using prime mover as a DC shunt motor. When the DC shunt motor is connected along with the flux control method, we can control the speed above, say, the speed above the rated speed. We can get here the speed above the rated speed. So in this mode, whenever we are driving the DC motor in the flux control method, we can get here the speed above the normal speed, or say above the rated speed. Other machine which is connected to DC shunt motor is the DC generator. That is connected in the self-excitation mode. So what is the self-excitation mode here? The self-excitation mode means initially, whenever the machine has worked before for any practical, there is some residual magnetism present within the field winding. Due to this residual magnetism, initially whenever the machine has started, the shunt motor is started here as a prime mover, very small voltage will get appear across the A1 and A2, that is the armature winding. This voltage may be around, say, 30 volt, but this 30 volt voltage is enough to pass the flux, or to pass something, or to generate here the flux. This flux will assist to increase the voltage across the armature winding. And again, say, this increase in the voltage. So what is here? Suppose the voltage is 30 volt across the armature winding. Whenever the current is passing through the field winding, this assistance will help to increase the voltage from 30 volt to say 40 volt. The field current may be like, say, 0.02 ampere. Then okay, so in the second case, whenever this increased voltage of 36 volt, again it will pass here the current of increased current of the field winding current, and this increase in the field winding current, again it will increase here the flux. So this increase in the flux, again it will, say, increase the voltage from 36 volt to, like, say, 45 volt. So this process is cumulative, and step by step the voltage is going to be developed here across the armature winding. And at one stage we can observe that the voltage across the armature winding will be, say, 220 volt. So this graph we can draw here, the graph of field current versus the EZ. EZ is the generated EMF. Generally, say, in case of shunt generator, whenever we are going to measure the voltage across armature winding, so this voltage is generated EMF. And whenever we are going to measure here the voltage across the two terminals of the A1 and A2 at the terminal box, in the terminal box, this voltage is a V. So why there is difference in the EZ and V? The difference in EZ and V is due to the IRA drop, the drop across armature winding. And okay, so the second drop is a brush drop. Generally we are using here the carbon as a brushes, and whenever the brushes are considered as a carbon, okay, so we are considering here the 1 volt drop across the each say brush. So in this particular experiment, okay, so we can conduct here the O.C.C characteristics, we can draw here the graph, and okay, so finally okay, there are no calculations for the practical, only you have to draw the characteristics of field current versus the generated EMF. Okay, so in the internal characteristic, okay, so you can have that characteristics. Whenever you are going for the external characteristics, then okay, so if the load is connected across the A1 and A2, then okay, so current will passing through the load, and okay, so you can draw here the characteristics of load current versus the output voltage. Load current versus the output voltage means terminal voltage. So this is called as the external characteristics. Okay, so these are the two observations in this particular practical. So next practical we can see in the next session.